All right, Algebra 2 students, welcome back to Mr. Kimes' classroom. And this video, we're going to be doing section 1.4, which deals with absolute value equations and inequalities. So some quick things here, and remember, equations, that's dealing with an equal sign. Inequalities, that's dealing with less than or equal to, greater than or equal to, less than or greater than, okay? So just some things to remember there as we go down through. A big key here is going to be understanding and being able to identify what it means to be an absolute value. What does that mean? Okay. What does it mean to be an absolute value? Well, here's the thing with absolute value. It is pure distance from zero. It is the pure distance from zero. It does not have a direction. You think about numbers like 5, -10. 5, you think about 5 positives going forward, 5 steps going forward. And then you would think about -10 as 10 steps going back. Big thing here is this is 5 steps from where you started. This is 10 steps from where you started. When we're talking about absolute value, that's the signs like this. This is the brackets. It's asking the distance from 0. How far is 5 away from 0? Well, if I've got a number line out, 0, 1, 2, 3, 4, 5. How long does it take me to go from 0 to 5? 1, 2, 3, 4, 5. Thus, the absolute value of 5 is equal to 5. Notice I didn't do anything with signs. Well, what's the absolute value of -10? Again, we can draw a number line here. We know -10 is down here. I would have to get to 0 here. How do I get there? Well, let's count. -10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Obviously, I kind of trailed off there. But what is it? How long does it take you to get back to 0? Well, 10 steps. So -10, the absolute value of -10 is equal to 10. The negative goes away. Okay, the negative goes away. So if I ask you a question, or if I give you an equation, the absolute value of x is equal to 15. What are the possible values that you could plug into that and get 15 out? Well, we know that 15 equals 15. Well, so x could be 15, but that's going 15 steps positive, right? 15 steps in the positive direction. If I'm going the other way, negative, or backwards, that'd be, so that's or x could be -50. There are two answers. Two answers. And there should be two answers with absolute value. We should be getting two different answers. So that's kind of a crash course on absolute value. Now let's see if we can't, tackle some problems here. It says determine if the following numbers are solutions to the absolute value equation. That would be a great time in the video. Pause it. Just pause the video. Take some time to write down the questions. All right, now that you got the questions written down, let's see if we can't answer them. I want to know if -3 is an answer to this thing. So I'm taking this -3, I'm going to plug it in right there for us. So I have absolute value of 6 times a -3 plus 20 is equal to 2. Well, 6 times a -3 would be -18 plus 20, the absolute value equal to 2. Well, -18 plus 20 is 2. Absolute value of 2 equals 2. Yeah, I think that's true. So is -3 a solution? Yes. Yes. -3 is a solution. Okay, let's jump over here. Is this -3 a solution in here? Well, that'd be 10 times a -3 plus 4. Absolute value of that equals 10. That'd be a negative 30 plus 4. That would be a negative 26. Negative 26, the absolute value of that is 26. Is 26 equal to 10? And that, of course, is not true. So, no. Negative 3 is not a solution. Great time, pause the video, write these two down, and we're going to see if we can solve these. All right, now that I gave you enough time to write down the questions, because you paused the video, we are going to try to solve them. I know that there's always two answers. Thus, there has to be one positive version. Not necessarily a positive answer, just a positive version. And then there is a negative version. Let me show you what I mean. Okay? It says a positive version. Great. That means I am taking this box thing here, and I'm going to make it the positive. So if I make it the positive, it's basically like I replace the absolute value signs with parentheses. That's 7x minus 5 equals 2. That is known as the positive version, right there. Now if I went and I tried to set up the negative version, I do the exact same thing. The only thing that I'm changing is I am going to put a negative sign out here. You can see it. And my original box here became negative down here. Became negative. Now I just solved the two equations. These should not be hard for us to solve. Add 5. That's 7x equals 7. X equals 1. There's one answer. Oh, okay, this negative here. Now I could distribute. But wouldn't it be easier if I just divided by a negative 1? If I divide by a negative 1, these will cancel. Oh, didn't mean to push that. These will cancel. Oh, do it again. These will cancel out. Thus, I'll have 7x minus 5 equals a negative 2 over here. Add the 5. Divide by 7, and I get 3 sevenths. Again, do not put that in a calculator. Do not even attempt to give me a decimal answer. I want 3 sevenths. And I have 2 answers. I have my 2 answers. Okay, let's see if we can't set up the other problem. Set the other problem up. I would have the positive version, which would be 3x plus 4 equals 4. And then the negative version, okay, that's 3x plus 4. That thing is now negative equals 4. Now I just got to solve them. Solve them down through. Well, subtract 4, that would be 0 on this side. Is this true? Sure, I just divide. If I divide, I get 0 divided by 3. That's just 0. That's one answer. Here, I think I'll get rid of this negative again. So I have a negative 4 over here. I got 3x plus 4. Subtract 4, subtract 4. I'm getting a negative 8. Be careful there. And then I divide and I get a negative 8 thirds. And those are my 2 answers. All right. Let's see if we can't do a little bit harder problem. Take your time, write or pause the video and then write down these problems. Now that you had a chance to pause the video and write down the problems, I need to talk about these before we can actually do them. Here, we got a bit of a problem. The absolute value is the box part. And it's not isolated. Meaning that 2 right here, this 2 out here is messing with me, so is this negative 1, and so is this, that subtraction of 1 and that addition of 5 on the other one. My first step is to isolate the absolute value. It's got to get isolated. That box part's got to get isolated. So what that looks like on this first problem on the left here is I would need to add 1. Okay, that would give me 30. So I'm getting rid of those, and I still have this absolute value here, and I got my 2. Well, get rid of the 2, that means I have to divide. When I do to one side, I do to the other. These will cancel out. I still have the absolute value now, and it's 15. Okay, that's not so bad. Now all of a sudden, it becomes just like the problems that we did before. Well, remember, the problems I did last time, I said there are 2 versions. We got a positive version, and we got a negative version. Well, all right, let's write them out. That would be 3x plus 15 equals 15. And then I would have 3x plus 15. The negative version of that now equals 15. The negative version. Now I just need to solve it. Well, nothing to do here on the first one. Just subtract 15, I get 3x equals 0. Divide, we saw that same thing happen before. That's 0 there. I don't like this -1, get rid of it. I get 3x plus 15 equals a negative 15, again because these -1s cancel. Subtract 15, I would get a negative 30. Divide and I get negative 10. And I have my 2 answers. I am now going to pause, and I am going to let you try the other. All right, now that you've had a chance to try the other one on your own, you should have taken this 5 away. So I have the absolute value of 2x minus 10 equals, oh, if I subtract 5, that would be what? That's 18. Now I need the positive and the negative. So I got my positive version over here. That'd be 2x minus 10 equals 18. And then I got my negative version. Some of you have probably been noticing that I could be just writing 2x minus 10 equals a negative 18. Because I end up dividing. No biggie, we could do it this way too. Add the 10, I get 28. Over here, similar method, I'd add the 10, I get negative 8. Divide by 2, I get 14. Or I get a negative 4. Alright, so there we go. Looks like we're powering through this stuff. I really don't think I need to do another example. You got plenty on your worksheet to work through. Make sure you're asking me in class if you're having trouble with these. And then we get into the inequalities. We already know that inequalities have less than or equal to, greater than or equal to, less than, and greater than. These are solid dots, and these are open dots. And the big thing here with inequalities is there are more than one correct answer or number that makes the inequality true. Because there's more than one, that means that we get the pleasure of graphing. Must graph all of these. So you gotta graph. Alright, let's try some. I don't think I'm going to do these two here. Feel free to do these. Okay, I got some on my written notes if you wanted to look back at the answers, but I don't think I need to do these really. I do want to get into the graphing. So, when I look at this, again, first step, isolate. Absolute value. Gotta get it by itself. Okay, that means I gotta move this through. That's 8 minus x, absolute value of it, is less than or equal to 2. Oh, now I'm ready to get rid of my absolute values. I need a positive version. Well, that's 8 minus x is less than or equal to 2. And I need my negative version. Well, that's negative 8 minus x at quantity less than or equal to 2. Now I'm going to solve them just like we did the linear ones before. We're doing the same thing that we did before, but now we have 2 of them. Well, I can do it a couple different ways here, really. I've seen a bunch of different people do this different ways. I think I'll subtract this 8, though. That would be a negative x is less than or equal to negative 6. I want to get rid of this negative, so I'll divide by negative 1. If I divide by a negative 1, though, that turns this sign around, though. Oh, well, look at this. On this side, I also have to divide by a negative 1. That'd be x is, divide by a negative 1, I got to turn this sign. That's a 6. Here I will subtract 8, I get negative x greater than or equal to a negative 10. Divide by a negative 1, divide by a negative 1, I get x, I get a 10. I divide by a negative, so I got to put that sign. And now I just got to graph it. If I draw my graph, I know 10 is bigger than 6. 6 is supposed to have a closed dot. I need x to be bigger than, that's that way, to the right. X should be less than 10, okay, or equal to, so it's closed. Now let's try this other one over here. I said to isolate the absolute value first. Is it isolated here? Well, it appears that this whole thing is by itself, so yes, it's isolated. Great, then I just need a positive version, a negative version. It's 56x plus 1. Then that's 56. Oh, let's wrong that. 56x plus 1. Absolute value is this. This is when you're splitting it up, so I have the positive version, this is the negative over here. All right, now I just have to solve it. Well, I subtract 1 here, I get 5. Now divide by 56, and I get 5 56. Here I got to divide by negative 1. Oh, I divide by negative 1, I got to turn my signs around. Then I got to subtract 1. That gives me negative 7. And then I divide by 56 again, and I get x is less than negative 756. I know that these two are correct, but I got to graph it. It has to be graphed. I know a negative number is smaller than a positive. They both have open circles. I need things bigger than 556, that's to the right. I need things smaller than negative 756, that's to the left. And I have that solution. That should be good for the 1.4 notes. If you have any questions, please make sure you're asking me during your work time.